Welcome to screencast number 2 in the Ruby on Rails screencast series on developers.To. Today we're taking a look at the Model View Controller, also called MVC architecture framework, and Rails MVC support. Understanding MVC is important to understanding Rails conventions, to following best practices in Rails development, and as a pattern to help your application designs. Model View Controller is a way of thinking of your application in 3 parts. Your model supports business logic. Views provide a way to interact with the models, and controllers connect the models and the views. Model View Controller is not unique to Rails. It was first described 30 years ago. Though Rails did not invent MVC, it closely follows the MVC pattern. Today, we'll take a look at Rails implementation of models and touch on why your business logic belongs in the model layer. First, we'll create our demo application, ECD screencasts. And the database. Then create a Rails model. The model script takes the name of the model and the attributes of that model. Our screencast model will have a title, a description, and a published flag. When we run the generate model script, you can see Rails created for us a screencast piece of Ruby code, which is the screencast class, a couple items for test, and this migration. We'll take a look at the migration in a minute, but the migration creates the database table for us. So finally, let's run that migration to create the database table in support of the screencast model. And let's take a look at what Rails has done so far. Rails created several new files for us. Let's take a look at 2 of those. The first is the database migration. Rails migrations are Ruby code intended to create database tables for persisting model data. When I ran the rake db migrate task, this migration was executed in the backend table created. When running the model script, Rails also created a Ruby class in our models directory called screencast. Rails uses active record for database-backed models. This class inherits from active record, which provides a connection between our screencast model and the database table, as well as between a screencast model and other models we'll create later. Rails implementation of active record also provides convenient methods for enforcing business logic, such as the requirement that screencast titles be unique. Because our screencast class inherits from active record, we can now easily create and update screencasts. Let's see how. Script console provides an interactive Ruby shell with the Rails environment loaded, allowing us to have the same interaction with our models that our views and controllers will have. Looking at our new model through the console reinforces the idea of separation of concerns between each MVC layer. For example, we can create a screencast using create. We can save it. We can find a screencast. We can update our screencasts.